Can people hear me? Okay, great, excellent. Just let me know if you can't. So this presentation is on the Internetable of anything to everything. And actually it's a vision of where we could go next, the next wave of the Internet of Things, looking at it from some different perspectives. The work, well, it emerges with working with Stefan on a number of different projects and ideas over the years. And we've been building and thinking about these new emerging technologies and innovations and how they work with computer science, in electrical engineering, in the humanities, and what that might mean. You know, what is this more holistic view of the world, of inclusion of technology? Where does it sit in that place? Before we get to that, maybe there's a little bit to think about the Internet of Things. So, am I right in assuming that everyone here knows about the Internet of Things, have had some kind of experience?
If you want to try and move your microphone a bit.
I will. I can try. So, are people? Yeah.
The lights on the screen is kind of.
The light. So the lights.
Oh, it's here.
Oh, I see you want the lights out.
Is that better? Is that what you wanted?
Yeah.
Is that good? Okay. So there's a lot out there about the Internet of Things at the moment. It's quite been emerging over the last few years, and it's become very commonplace, especially in industry, to talk about the Internet of Things. And it's a whole drive from the industry coming through, which is unusual in some of these environments. Why does that happen? Why is it sort of being more industrial driven? And that's resulted in a lot of new kinds of applications, but they're quite siloed. One of the things that I've been working on, one of the projects that I'll talk a little bit more about later, is the Microbe It Project with the BBC. And as you can see, the microbits in there. And one of the kind of exciting things about the microbit from an education point of view, but I also think from a more general point of view going forward, if we really do want to create the Internetable of things, of everything to anything, is really the fact that you can program your device from your mobile phone. At the moment you can't do lots of things with it, but from sort of secondary school point of view that's quite amazing. You've got a lot of onboard sensors. And you can do all kinds of data tracking and interesting things that you can develop and design yourself, and do some simple kind of interactions with the device. So suddenly that opens up an idea for us to think about what that could scope to this more personalised experience and ownership of the device. So you'll see many kind of mappings of machine to machine, people to people, people to machines, and all kinds of configurations of these systems on the internet, talking about this vision ahead. And I think it's a very important vision. It's quite broad. But I'm going to take you on a slightly different journey that I think will be a little bit different to what you've perhaps heard before if you have been looking at the Internet of Things. And I'm going to look back a bit to go forward. And then I'm going to discuss two projects, and then the vision. How do we step forward, and what might that idea be? Can this vision seed forward into something that is more community, social driven ideas? And that's where you come in. So I want to take you back to the 1980s, which for some of you, you may not know about, but they did exist. It was an interesting time. And there was a piece of work that was coming out and that was quite important to my research, that follows on later, that I built on, which is something called the reflective tower reflection in computational systems. And Brian Smith had this idea that software systems could just perpetually scale And then how would you manage that? What did that mean about this inspection of software, of inspecting itself? And there's potential for IoT, which we'll come back to at the end, is the systems of systems thinking. Now, it's not necessarily that Brian Smith was thinking about that in this sort of Internet of Things. The Internet of Things, as we know it today, didn't exist then. But he had this idea of systems, that systems could live inside systems and could tower up, and you could use the power of that we see sometimes in languages today when we're programming. You see the first IoT app kind of idea coming out where people start to look at this vending machine to see if there's any drinks left in the 80s. And that's kind of one of the reference points where we start to see this notion that we can interact with these objects in other ways. But it's the start, it's the very beginning of these ideas. And there's a lot of work in AI at that time, a lot of work in expert systems. There's a lot of theories about robotics. People are getting quite excited about robotics, and that's quite important to the Internet of Things because that tells us more about sensors and connectivity and so on, and the IoT opens that up, so that's quite important. And then going forward, as we get towards the end of the 80s, although to be fair to Patty Mayers, hers as well, 87 was her thesis, she did something called computational reflection. So Brian Smith really looked at languages as being able to describe languages of themselves. So if you like, compilers inside of compilers, you know, operating systems inside operating systems. So you'll be aware of those kind of things in bootstrap systems. But she really looked at this conceptual reflection. So you've got structural reflection. We use that when we program today, the data program separation. Procedural, you will use that when a language wants to configure something about itself. You see that in bootstrapping. But this is conceptual. So this is where you start to see a program running and it being monitored at a meta level and being able to interpret what's going on and to reshape how that would change. And she did it in object-oriented languages. And that was a fundamental shift in how we could think about the management of software systems. Why is that interesting to IoT, and why is that going to be interesting today? That's in self-governing systems. So you will have seen things about autonomic computing and so on. Those kinds of thinking are only possible if those kinds of things exist and live in your languages. So that's kind of an interesting part. What else was happening at the end of the 80s was that AI was kind of falling out of favour a bit. Long promises of many, many things to happen. But if you look at today, AI is very much back in favour and very much in demand in industry. So you might say, well, what happened? Well, actually, what happened was all the really fundamental things that could work directly into society moved into products while there were still things going on where people were still thinking externally about how those things would work. And what you start to see is that people start thinking, oh, AI is not really working. But what happened was people didn't present their products with AI. We were uncertain as to, people weren't comfortable with thinking about AI in systems, whereas today that's a different experience that we have. You'll see, you know, this analytics, this data, this algorithms, machine learning and so on. There's quite a big push in that space. But multi-agent systems really come into their own. Highly distributed, open, big systems are coming out. And it's when Honda, and many others, I could have picked a zillion of different things, they're going to make a walking robot. And that's important to think again about the sensors control and so on. And AI was in a bit of a confused point because we had robotics trying to do this, doing this control theory and being able to get robots to move around. We had AI doing all this kind of computational, how can we learn about things? And then we had trying to put these systems together, and they didn't quite work. And you had systems that could, without any intelligence, leave a room, manage and plan its way out of the room, and then a system with intelligence that couldn't. So why did that matter all to me? Well, I was very interested in that work. I was doing my PhD, and I'd been given this really interesting problem to solve called high-level strategic planning in computer systems. So I was trying to think about, well, how do planning systems, robots doing planning, how do we intelligently do that? And my work in particular was about self-configurable software systems. But I was very interested in robotics. How do those sensors work? How do we connect to us? How is that real world going to work? At the time, of course, to do robotics and even later on, any of those things where you really needed the hardware and the platforms, they were expensive, challenging, difficult. They still weren't ready for use. But it was important that you had this ability for flexibility and robustness. And I remember thinking that, and that was part of my work, part of my contribution of my work. And that stayed with me throughout many of the systems of looking at what is a computational system, where is it bounded, how can it control itself, how can it be part of a system, how can a system be open. And there are challenges that we face today. But what about IoT? Where was IoT? So IoT, out of the 1999, came out as this idea. But still, today, it's been the last few years where it's really made a big hit. And fundamental work, so of course, Dr. Poslad's infamous, famous book, which I think just defines fundamentally what IoT is about. It gives you all of the details, amazing piece of work that when you read through you think, well, yes, those things are possible. How are we going to make those things happen? I was also very fortunate to work with Abdel on his thesis, where he was looking at a formal model of how are these systems going to configure and build on each other's systems. And he implemented this way of communication, of a communication stack, of enabling different kinds of entities to come together. But I'd say more fundamentally that was also happening was the grassroots, the maker movements, the maker communities that were looking at STEM. And they don't talk about IoT, but that's science, technology, engineering and maths in more informal settings. And they were looking at this way of bringing communities together who wanted to build and create things. And that's really important. And it's important to IoT if we want to see it as a global enterprise and society-enriched experience. Because what happens in the maker community is that you don't need to know everything when you enter into the community. You just have to have your ideas. There'll be people there that will work with you. It's very collaborative, coach-based. And that driver, I think, has been quite critical because what happened in the 80s and the 90s was manufacturing and engineering, again, was very expensive, whether or not you were trying to do robotics. What was happening was that people were coming to university, people were realizing, well, actually, people haven't had that hands-on experience. When you build something, it's completely different to thinking about the theory of it. Because you engage with it, it becomes very creative. This idea of imagination of movement is externalized. It's a very, very powerful way to really connect with what you're working on. And there's a lot of that happening in the maker movement. So what happens in the STEM side of things, and more educational, they're saying, well, that looks kind of important because people are engaging and they're learning, but how do we bring that inside a formal education? And there was a lot of work by Bevan and his colleagues where they came up with a learning dimensions framework, because one of the criticisms was, well, it looks like fun, but are people learning? Do we know that learning is going on? And can they really make things? And they did a lot of work in investigating that across a broad range of kinds of people learning and coming together and what that could foster. So we're now at this point today where we have a lot of diversity going on, which makes sense in the field of IoT because everybody is working on a lot of different types of projects. It's quite diverse. But you also have a lot of people who are not quite sure what it means and how to include it in their workplace and in their life. We have lots of applications and changes that are enabling that to happen. This is taken from Nordic. Nordic are very big in the underwear hardware and the technology that support what you use in the Internet of Things, what's in the Microbe It, they contributed to that work as well. And what we need to think about now is that how are we going to bring that into a broader perspective in usage? What does that mean? So here you see, again, a bit like your mobile phone, you will see all of those applications. But how can you own it? How can we own it? How can we make our own Internetable of things? And how can we take it? Something like this. Can it enable us to move forward? So there's lots of things have to be in place, but where can we go next? So I'm quite interested in that. What's the process? What does it take to bring a community and engage with the community in those experiences? And not just scientists, designers, and people who've never used technology before. So like a maker-style community that engage with doing something. So where do you start from that, with that? So this was one of the projects where we were looking to investigate what were the potentials of reshaping and changing and thinking about that. I've run many projects, but this was one I ran last year with Greg's City Academy. And they're year 10 students, so I think they're 15 years older when they came in. So they didn't really know much computer science. They certainly didn't know about the Internet of Things. And they, the teacher was teaching them a bit about computer science, teaching them some Python. They knew a little bit about Python by the time I met them. And the approach that we take is that we say, well, what kind, if you wanted to build a smart city, what kind of problems would you like to solve? What's the kind of things that are really annoying you that you would like to do? And the reason for doing that is that the authenticity of that, the meaning for you, for the person who's going to engage with it, means that it'll have value. And they'll learn about it, and they'll engage with it, and they'll build it, and they'll collaborate. It doesn't have value, then it becomes very difficult to sustain, and the learning of that process becomes harder. So we spent 2 months working together. They had other classes to do and other things to do. And one of the very interesting things is the brainstorming, is the design process. So while technology is important in this particular instance where we're creating something that's going to be using sensor-based and different kinds of technologies, it is also important that you have a design space, that you know what you're making for what reason. And in that approach, you actually widen participation. So if you want to work with people from other groups, you have to start from the diversity and inclusion from the beginning. You can't bring people in at the end and say, here's this nice object that I've made, now use it, because that's harder to engage with. So these students came up with a number of different projects and a number of different brainstorming. Finally, they had 3 projects they wanted to work on. One was in the home. They wanted to build this smart controlling glove that could work in the home. One was on mobility. How could they support people through a mobile device that worked with them, which they call their dog bot. And then the other was in the school. They wanted to look at some way of dealing with this problem where lots of students, people throw away copper. Could they use that? Could they transfer something around and collect those coins and create a system, sustainable system? So they went through lots of iterations, and it was a lot of design. It was quite interesting. And we didn't have the right kinds of tools to do it with, so we didn't have an already nicely designed sensor glove. And we had lots of bits of stuff that had to come together, so we had to repurpose things and rethink how could we get this particular sensor to do something else in design. Now, to do all of this required a big group of people to come together. So we had designers, we had people from industry, we had people from academia and research. We were all collaborating and sharing and building on each other's ideas and to help the students think about how they were going to do it. The students had to build it in the end and produce what they produced. So the glove is actually was just an ordinary glove, and we added, they added some sensors. They used Arduinos to do it. We had this semi-mobile robot that Middlesex University let us use. In fact, they came down and helped us to understand all the complexities in that, and then the things that we could do with it and how we could make it into a dog bot. And they saw that as something that might be useful for helping blind people in the streets and moving around and give them more information about the environment around them. And then the coin collection example was this idea that you come in and you've got this reward system, and it collected up all the coins that you put in, and that gave you access to something in the school. Sort of idea, which was quite nice. So it was kind of very community driven. They had these ideas of doing things in the community that made sense for the community. And then as if that wasn't enough for them, they then had to go and present at the Festival of Education in front of lots of people, which they did very well, to explain what they'd been doing. So it was quite an exciting time. So that was one project. And then, now I'm going to talk a little bit about the microbit, and then to this vision of going forward, of what could happen. So the microbit was launched back in March 2015, although the BBC had been working on this idea for some time, from about 2012, of what they wanted to do. And they saw this sort of approach coming into year 11, age 11, year 7 students, bringing this device and rethinking computer science. And I don't know if you're probably aware, but in 2012, big shift in computer science happened in schools. Re-looking at the curriculum, rethinking about the curriculum, and new curriculums coming through. Students were going to have to program in one visual language and one text language and so on. So there's a lot of things going on. And for the teachers, that was quite nerve-wracking, because for some of them who were going to then be teaching this were not necessarily from a computer science background, and the support wasn't easily there. So there's one thing to have access to resources, there's another thing to teach it, as we all know. If you've ever done any teaching, it's great if somebody gives you a set of PowerPoint slides. It's a whole different thing to have to teach it. You have to know what it is you're doing. So there were lots of challenges in there, and that sort of inspired this BBC team to think about, well, what could we do? What more could we do? What would be interesting? And how could we bring in this kind of maker sense within the classroom at an early age? And they looked at things like Arduinos. And I mean, I've worked with kids with Arduinos, and I've worked with adults and so on. And it's a bit challenging if technology is not your thing, and you're not from you don't have a lot of computer science and you're not sure. Sometimes things like the Arduino can be a bit challenging, because you've got a lot of cables and they're quite that you're putting together, and it can seem very complex to get going. Once you've got going, it's fine, but there's that barrier of where you're trying to bring people in. So how could we make that a bit simpler? So they came up with this onboard sensor. So it can't do as much as an Arduino, but it can get you going quickly. And you can extend it with an Arduino. So it enables you to progress, but it also enables you to progress within the components that you have, and it allows you to connect components together. So that was seen as a way of opening up the participation. The other interesting aspect about this was the look and feel, which is something I think in STEM we kind of lack a bit, we forget about. We kind of look at science and we don't think it needs to have a sort of aesthetics. We think it comes from perhaps the query of trying to understand something. Now that's true probably for all of us in this room. We perhaps engage with it on that level, but it isn't true for people who are coming from a different perspective. They're kind of trying to connect to it and see a purpose, and they're not seeing science as its own purpose or engineering as its own purpose. So one of the interesting things that happened with the microbit is that, I mean, it's gone through a lot of designs. You'll see it's got this face, it's got all kinds of features to it. They give it this appeal. You want to touch it when you see it, and you want to see what it does. I don't know if you want to pass it around.
Thank you.
And you kind of want to look at it and see what it can do. And so you just, and that's what children, young students wanted to do. They wanted to touch it, which is the first good sign, because that got them thinking. Now, it's not enough. The aesthetics is never enough. You've got to be able to do something with it. You've got to go beyond that and be able to program it. But one of the key things that came out of the initial studies was being able to do something quickly, first of all, being able to get some feedback, build up your confidence. So that was kind of interesting in that it promoted that.
Can I just ask one question? With some of these electronic components, you're actually told not to touch them because you might electrically, statically damage them. So they must have got a fail-safe into
They have. It's gone through rigorous, it's been delayed, rigorous testing to be exactly where it can be at the best success rate that it can be. It's had to go across very high standards for that. So it's been a lot of work for people engineering, which also says something about these kinds of things. They aren't easy to reshape and change to create a new product and to manufacture. It takes a lot, but we're getting better at it, I would say, and that is the possibility going forward, for the opening up. So you're right, you are told that, but when you're building with the Arduino, you have to build with a breadboard. So you have to start with a breadboard, and you have to have your microprocessor. Then you've got to connect it together. Now, even just to get a flashing light for some students, there's a lot of confusion. And it's not that you shouldn't understand that or know about that, because you need that if you're going to be in electrical engineering, in physical computing, in the Internet of Things. You are going to need to understand that. But just to engage, just to get through the first steps, to open up, make that a little bit simpler, but extensible, so that you can progress. So that was one of the key things. This language is touch developed, so this is by Microsoft. And there's two other languages that the Microbe It supports, which is JavaScript and Python. So it's able to move from a visual language to a textual language. You do have that option to move across, which is very helpful for students starting out with the programming. There's some limitations to it, to the environment, but in engaging with a community that probably before this couldn't have engaged very easily, there's been some reduction in that. That's given it a possibility. There's a lot of amazing resources that lots of the partnerships have built up, and people have worked very hard on making this accessible, both working with the teachers and working with teacher students and in communities. So that's been very powerful. It launched back in June, I think it was it June or was it July, where we launched the whole event on a public event, and I created a Padlet wall of all the amazing things that people had done using the Microbe It to try and demonstrate its flexibility and functionality. I mean, there's loads more. There's lots of stuff out there to see what people have done. It's incredible. It's very creative. And I think that was the other thing, is that people don't see or engineering or the Internet of Things or computer science as creative. And they think it's innovative. They don't see it as creative for people who are outside. And I think that's a shame, because it's one of the most creative, compelling experiences to be in when you build something, when you engage in those imaginations of movement in your mind and you make it happen and you share it and you're collaborating. It's fantastic. But it's one of the barriers. And I think it's changing. Culture is changing, but we've still a lot of work to do to ensure people have a go and come in and try to understand it. So what happened with that, as we were working through the data and thinking about it, and looking back at the Fab Labs. So the Fab Labs said, well, the Fab Labs came out with this idea that people needed to do more engineering, build stuff, create stuff, and they needed to be closely associated with schools. So they were looking at that kind of process. And one of the arguments was that you did an experiment, and often it stayed in the lab. The Microbe It or microbit type of technologies can change that. One of the other really interesting things is that the microbit can go with you wherever you go. It's not a load of technology that you have to take. So you can take it to the classroom, from history to computer science. You can take it from school home and do things with it and start to experiment and explore with it. It becomes something that you can do. So we started to think about this Maker Lab in your pocket. And you could share designs, you could discuss, you could debate things. So it's kind of, it starts to move the thinking on that you're no longer stuck just in the lab with the thing that you're doing. The students can start to think outside of that, and they don't need to have a huge amount of tech and things with them. So that's kind of interesting. So now I want to move on to the next bit, which is this bit about the Internetable aspect of what can we do? Can anything become Internetable? Is that a possibility, and what might that mean? So in a sense, there's always this notion that you go through waves of change. And with technology and the pace that it's changing at the moment, it can be from one day to the next. It's a really very exciting time, but also equally uncertain. So the history timeline, I'm not sure what that is going to tell us. If you look at the past 5 years of the changes that have just happened and what we're able to do now that we couldn't do 5 years ago, or the impossibilities of that. So what if we could take that Maker Lab to the Internetable of anything to everything in your pocket? It's a question. Because in some ways we might think, well, some of that's been done, but in a general way it hasn't been done. What if your Internet of device could talk to other devices, any objects, food, etc.? Well, you might say there's applications that can do that, and that's true. But does it let us get inside the black box? So Stefan was saying, sometimes you're told not to touch parts of devices, you're told not to open things up. We tend to recycle in a way of replacing things because we're told not to look at these things. And what if we could tell the IoT device what kind of questions to ask, or what kind of information we needed to know, that I needed to know about this desk, about this room, in a way that made sense to me. So if we could have our own R2-D2 that you could put in your pocket, because I always think about R2-D2, if any of you have watched any Star Wars, being able to communicate. You could communicate with machines, but you needed somebody else to translate what he was saying. And so that took another robot. So it's an interesting way to think about it through the microbit, because you can actually program your microbit from your phone. So one of the questions I often get asked is, well, why wouldn't you just do all these things on your phone? Well, your phone, unfortunately, or fortunately, well, apart from it being very, very expensive, and you probably don't want to take it to bits, but if you do take it to bits and it doesn't work again, you probably have to pay for it, another one. And you probably lose all your data, and the manufacturers will say, well, that's your problem. But if you can program your device, your IoT device, whatever that is, be it microbit or something like that kind of thing that can do that, to talk to other things, to do things with your mobile, you then have this possibility that you could start to extend and think about how you would connect that. And so you might want to say things about, as I say, something here. Like when we were trying to figure out how to communicate these sets of systems together, you kind of want something to act for you, to be able to connect to that technology and give you information. Perhaps it can tell you something about the density of the wall that you're looking at if you want to fix it. At that point in time, perhaps, so there's a device that can tell you about the food, the ingredients of the food, what that makeup of the food is. That's a separate device. We don't want as individuals, hundreds of devices. We kind of like, and I think it would make sense for us to have a device that we could extend and we could make to communicate and connect to all of these things. Now, up until recently, the possibility to be able to perhaps do that was quite complicated because, you know, I have a huge box of Arduino kit and sensors that can probably do all kinds of things. But, you know, to carry that around with me, it's hardly going to go in my pocket. But with your onboard sensors and a kind of idea of extensibility that you can program from your phone, that can then, you can say, tell me something about that wall that you can extend. You've got the possibility to be able to extend the device in different ways, get different information back. Or tell me about that food, you know, and it might say, oh, I don't think you should eat that, it's a bit out of date. And, you know, it can give you information. We can start to own those applications that become for us in a way that we haven't been able to before. And the reason why that might be important to us is, you know, there's a lot of things, you know, happening in the health environment and so on, but they're all driven by specific applications. And we do talk about this personalised system and possibility coming forward for the individual. But many of them are driven by specific types of application, like applications that you get on your phone that you kind of have to use them as they are, or you have to know how to program it to change it. And there are big gaps, there are big jumps between that. So if we're thinking about these smart cities and future cities, future healthcare systems, future ways of us having more information about things that interest what we would be interested in, it's unlikely for most of us that we are going to have, you know, a smart home as in some of the smart homes that you see out there. They're hugely expensive, they're hugely resource demanding, and I don't know how scalable they are, and they're very power hungry in certain ways. They sit, you know, for most of the time having a lot of infrastructure into them. Now they may be the future, but the future for us now as we're progressing through for most of us in our everyday homes where we live, that's going to be a different future. And we can make that future, perhaps we can create our own personal ubiquitous access. Design kind of ad hoc as we need to, as we understand how to talk to these sensors and create the kind of connection with anything in a way that makes sense, where the device can tell us how it can connect. And there's a lot of things that are changing. We're still, I would say we're still not there, but we're on the cusp of that now, possibility, for many reasons that are converging. So the fabrication technology, it's easier to fabricate. You've got things where you can sketch in electronics now. You know, it's kind of quite interesting how you can do that. So you have more accuracy, more personalization of those systems. You have 3D printers that can print different aspects of that for us now coming out, but still expensive. There's a whole new area of biotechnologies coming out where they're looking at biodegradable aspects of that. And that could be very interesting in reusability and recycling of technologies within our own set. And perhaps that's part of the future. Perhaps there's a future where those technologies can be reworked. So tangible query-driven interfaces. So we're starting to get to exposing the black box. We can start to inquire, inspect. We want to get closer to that. So extensible devices. Oh, that's good. I've only got one more slide, or two. Great. So becoming easier but not seamless. So devices are, and there's another question, so I put seamless in quotes because I think some of it is if we're too far removed from the black box, it's a problem. Because we don't know how something works. We can't get into it. You know, imaginations of movement. Unless you're in the field, that becomes problematic. That means we can't own it and adapt it in the way that we want to. So moving more towards that. So next steps more to be done. So at the beginning, I talked about 3 areas coming forward where I think that it's important in going forward. One was on systems of systems, so this reflective tower. Can we think about these systems of systems and configurability? If we want to have personalized systems that we can control, we have to understand in a community sense, in our design sense, as us as computer scientists, as engineers, how to do that, how to do this broader thinking, inclusion, and looking at barriers. None of this comes easily. It's not that we can do at the drop of a hat, otherwise it would be there. Self-configurable. So at the moment we have fragmented things happening, and by that I mean there's lots of silos of tools. You can control lots of different things through a variety of different ways, which is quite complex. But can we actually look at more meaning-driven? So again, back to what makes sense for me as an individual rather than a product. The product can do one thing. Can I be in a position to start looking at that management? So we need to think about the self-configurability of systems rather than these closed systems. Which brings us to self-governing. So Patty May's work on this relationship between object and meta, I mean it's broad work, I'm just looking at one aspect of what she did, was a self-governing system. And that's really important moving into privacy and security of data. That doesn't go away. Those problems will exist. But more humanistic-centered than machine-centered. So centered on what it means to the individual or the community rather than the technology itself. So this is my last slide. And so what we're going to do, well, Stefan and I have been working on plans and things of how to sort some of this out and talking to lots of different communities and people. And we're in the middle of putting together this new research group. And if you're interested to come and join and see what we're doing, it's IoT in the communities. It's looking at a broader aspect of that. So that's about the diversity, inclusion, so from design through to technologies, which is good because Steph and I come from these two different perspectives and our work can come together. So we're looking for we're going to be launching an event in early July, so it's in the beginning. If you're interested, you're very welcome to come and join us and work on these projects together. And we have other projects. Of course, I've got some projects on the Microbe It and things like that, and I've been talking to Stefan if people are interested in doing that. So that's where we think the steps are forward. It's going to take all of us working together to make that happen as communities. I think being human-centred rather than technology-centred, so really looking at the value to the communities for inclusion will bring IoT to a way of purpose and meaning for a much greater public than we have seen so far. So I just want to say thank you for listening. I hope that was interesting. And if anyone has any questions, I think I'm very happy to try and see if I can answer them. Thank you very much.